Azure Cosmos DB is Microsoft's proprietary globally distributed multi-model database service, and it is fully managed for modern app development. It gives high speed at any scale and is apt for fast and flexible app development. In this video, we will be covering overview of Cosmos DB, what exactly is Azure Cosmos DB, creating an Azure Cosmos DB, what are the request units, choosing a partition key, creating a database and container in Cosmos DB, and some questions.
In the end, we will also share details about our free Azure Data Engineer Masterclass, which will not only help you to understand basics, but it will also give you an idea of the learning path to follow. It will be helpful, especially when you're preparing for Azure Data Science certification. That's implementing Azure Data Solutions DB200 and designing Azure Data Solution DB201, which will earn you Azure Data Engineer certification. Welcome to another episode of Azure Data Science video series from K21 Academy, where we take you from complete beginner, covering implementing data storage and designing for data security, to all the way designing for resilience, including batch processing, analytics, architecture, and monitoring, as well as how to prepare for the Azure Data Engineer certification. We have taken a clip from one of our certification training program on implementing an Azure data solution, that's DP200, and in this clip our Microsoft certified trainer will talk about
Azure Cosmos DB. So, this is a clip taken from a module on building globally distributed database with Cosmos DB. Now, let's hear from our expert trainer on the same.
As part of module number 4, we are talking about Cosmos database, and we'll understand what's the meaning of Cosmos database, how do we create it, how do we query the Cosmos DB, how do we create any application in Cosmos with Cosmos database. So lesson number 4 is optional. It's not part of your certification as such. It's just FYI information. And we'll also talk about distribute your data globally with Azure Cosmos DB, right? So let's get started. So the very first thing is lesson number 1, what is Cosmos DB? So what is DB account, what is request unit, what is partition key? So we understand each component is an element of Cosmos database. So just FYI, Cosmos database is a very highly scalable, globally distributed database. So in the starting, when we create the Cosmos DB for the first time, it is having one endpoint. So you can see that here one Cosmos database account is getting created. So account is more like a wrapper, and inside the wrapper you can have multiple databases. So once the account is created, you can select the multiple regions in the world where you want to make your endpoint. So maybe if I have a distributed data application, so one of my endpoint can be South India database, South India data center. Another endpoint can be, another endpoint of Cosmos database can be West India data center, or another can be in East US, another can be in UAE Central, UAE North maybe, or another endpoint maybe in West Europe. So the application might be globally distributed and having all these databases are syncing with each other, and wherever the customers are, the applications are pointing to the nearest endpoint. So if any company requires database which is globally distributed, then Cosmos DB comes into picture. Now, something which I want to talk about over here is scalability. It's you can say we have options such as autopilot. Autopilot means as per the requirement, automatically Cosmos DB will scale out, scale in. So it's highly scalable. When it comes to performance, couple of numbers I want you to remember. So when read latency comes into picture, read latency is less than 10 millisecond. When we talk about write latency, write is less than 15 milliseconds. So remember these two numbers, and like how performant is Cosmos database. It's highly available. It is having multiple endpoints globally. So when it comes to availability, even if one of the endpoint goes down, we have more endpoints available from where we can read. So it's like active sites are there, and it's pretty high available. And SDK is available in all the programming languages with which you can create applications using Cosmos DB. So I'm taking back you to the next slide, and this is the account page. How do we look and feel like? How does it look and feel like? And in the lab, we will be creating it, right? So you have to hang in for the hands-on part. Now, before I go ahead, I want you to understand something pretty important over here. There are 4 things I want you to understand, or maybe let me use Microsoft documentation for that purpose. Now, check this out over here. Now we have various type of non-relational data stores are there. One of the data store is called as key value pair, and this is how the key value pair looks like. So if I want Cosmos database to become a key value pair and store information in key and value format, then I will select, you see this option over here, API, SQL API, right? So in this option, in the drop down menu, we will select table API. So if you select table API over there, it will become key value pair and the information will be stored in this format. Secondly, if I want document database, right? A lot of times you can say it's document databases are pretty easy to work with, schema-less, and you can say very flexible as such, and schema will be imposed on read, not on write, so you can write very fast as well. So if I want Cosmos database to behave like document database, I have two options which I can go for. First option is I can leave it like SQL core API, or I can select MongoDB API over there. So if I select Cosmos DB with SQL API, it is compatible with SQL. So SQL queries can run over there. If I select MongoDB API, it is still a document database, but now Mongo queries can run over there. So apart from this is called as graph database. So if we select Gremlin API while creating Cosmos database, this is how it stores information in graph format. And similarly, we have column family database. So if we select Cassandra API, this is how it stores information in column family. You can say in column family database like that. And the example of one column family database in the world is called as Cassandra. So these are various modes of Cosmos DB. So if somebody says that Cosmos database is multimodal, the meaning of that is it can have multiple modes like that. Like it can have various ways in which it stores information. It's a non-relational database, but it can store information in multiple ways. Graph database, graph manner, key value pair, document DB, or column family database like that. Now, how do we pay for it? So remember this line which I'm saying, one request unit is equal to the amount of resources required to read 1 KB of document in 1 second. Remember this. So if I have 1 KB of document, I want to read that in 1 second. So I have to provision one request unit to do so. So if I have 400 KB of document, and I want to read 400 KB of document in 1 second, I need to provision 400 RUs over there. Remember this. So what is request unit? See, now if in infrastructure as service, we have RAM, CPU, IOPS, and so on and so forth, by which you can provision resources, or provision in database terms, you can provision, let's say, throughput over there, read and write, how much can we read, write per second. However, now Cosmos database is not infrastructure as service, it's more like a platform as service, globally distributed database. So what did they do? They gave you one new term, and the new term is called as request unit. And request unit means amount of resources. Amount of resources can be any resource: CPU, RAM, IOPS, storage, anything behind the scenes which is required for you to read or write with some sort of can say throughput. So we pay in request unit. So you can assign request units to your database or the containers, and you will be able to read write accordingly. So if you try to read more than what is allocated, obviously we are supposed to get some error, and the error which we get is called as 429. So 429 basically means rate limit, upper limit hit. So what do? Either we give more resources to Cosmos database, or we simply enable autopilot over there. Autopilot means that it will automatically scale out, scale in. That's a pretty interesting functionality. Now, whenever databases comes into picture, partitioning will be there. And so one of the art of any database administrator or data engineer will be in terms of how to select the partition key. Now, if I select the wrong partition key, my queries will not be optimized. If I don't do partitioning, it will be pretty, you can say pretty bad. If I select the right partition key, and there is no thumb rule as such. For every time, you can say for every scenario, every type of data, every type of queries, the partition key can change. So what do? We do a reverse engineering. First of all, we go and check out what type of queries will be running. So maybe let's say I have 10 queries which are running over there. So we cannot make everyone happy. We can make maybe 70% of the people happy, or maybe 80% of the people happy. So out of you can say 10%, 10 queries as such. You will try to do the partitioning in a manner which can keep 6 to 7 or maybe 8 queries happy in that particular sense. So you can see why do we have partition? Why have a partition strategy? Having a partition strategy ensures that your database needs to grow so it can do easily and continue to perform efficiently. And continue to perform efficient queries and transactions. What is partition key? Partition key is the value by which the Azure organizes your data in the logical division. And these logical divisions are behind the scenes and physical partitions. Range of values, the more value your partition key has, the more scalability you have. But remember one thing, do not select a partition key which is having very unique value. For example, like cell phone as such, or primary key of some sort of or having too unique. If the uniqueness of the, we call this cardinality as such, high cardinality values. So if the unique, if the keys are not repeating, then your data will be too distributed, and that will be all. That's also a part of wrong partition strategy. During the session, I will explain more about partition. I'll take more time into explaining in using whiteboards and so on and so forth. However, so as you're just discussing about, to determine the best partition key for read heavy workload, review the top 3 queries out of the 5 queries we are planning to do. So do a reverse engineering and do the partitioning accordingly. Transactional workload, for write heavy workload, you need to understand the transactional needs of your workload. How are we doing the transactions as such? And based on that, we do the partitioning key choosing. Now, inside Cosmos database account, you have the database over there. Now, Cosmos database is equal to database in relational database sense. In SQL, you can imagine like that. And container is equal to table in a relational database. So if you understand what is SQL, you have seen, we understand what is SQL, right? SQL is basically having some sort of databases and tables are having rows inside there and so on and so forth. So container is equal to table and rows is equal to documents. Container is equal to table and rows inside a table is equal to documents inside container. Remember that. And database is equal to database. So we create databases, we assign the throughput over there, we specify the containers, and these containers are having some partitions, and inside that we store the data in some sort of manner, like documents might be there. So let's have a quick revision and a couple of more figures I want you to understand. So check this out. So you want to ensure there is 99.999% availability for read and write of your data. How can this be achieved? So what we can do, we can configure multi-region accounts and we can do multi-region writes as such. So you just need to enable multiple Cosmos DB endpoints, and then that high availability will, you can say, then the .9s will increase. What are the main advantages of using Cosmos database? Now, main advantage of Cosmos database is basically that it is global in nature. Multiple modes are there. Availability, minimum availability is 99.99. And latency is pretty good. In around tens of milliseconds latency is there, and actual numbers will be can say read latency will be less than 10 milliseconds and write latency is less than 15 milliseconds, to be in exact numbers like that, in that particular sense. So Cosmos DB offer global distributed capabilities out of box, and it is minimum availability of 99.99%, and response time of read-write latency is typically in the order of tens of milliseconds, right? And remember the actual numbers, less than 10 milliseconds and less than 15 milliseconds over there.
So that was a clip taken from one of the lessons from a step-by-step training program on implementing an Azure data solution. That's DP200. I would like to invite you for a free 90-minute session with Microsoft Certified Expert Trainer, where we talk about the Azure Data Engineer training and share information about getting certified by using our step-by-step roadmap to go from complete beginner to a certified Azure Data Engineer. If you are interested, register for a free class by going on to k21academy.com/dp20002. Additionally, we will show live demo, extract, transform, and load data using Azure Databricks. We will also share information about the certification exam. So you can register for free by going on to this URL, k21academy.com/dp20002. I will see you in another episode of Azure Data Science video series from K21 Academy. Till then, take care.